Earth Science, Chapter 6, Section 8, Water Supplies, Digging Deeper. Water supplies, sources of water supplies. In colonial times in the United States, most people took water from rivers or dug their own wells. Today, cities and towns need reliable and safe supplies of water for their citizens. Water must be collected, stored, and treated. There must be enough water to see a community through times of drought and times of increased water use. The two main water sources are surface waters from rivers and lakes and groundwater. There are 6 ways to increase the supply of water to a community: withdrawing water from groundwater aquifers, withdrawing water directly from nearby rivers or lakes, building dams to create reservoirs to store runoff, improving the efficiency of water use through water conservation, transporting water from a distant area by means of aqueducts, and converting salt water to fresh water, also called desalination. Let's look at Figure 1. In Figure 1, large pumps are used to supply water to a community. Many of these choices affect other communities. For example, suppose one town takes water from a river upstream. This decreases the amount of water available to towns downstream. Surface water. In most rivers, water flow changes too much from season to season to be a reliable direct source of water supply. Most surface water supplies are from large lakes or artificial reservoirs. These change less from season to season or from year to year. In Figure 2, surface water from freshwater lakes is a valuable source for human use. Dams are useful for providing a water source and controlling floods. One such dam is shown in Figure 3, and as you can see, Figure 3, a large reservoir was created from the Colorado River at the Glen Canyon Dam in Arizona. However, they have disadvantages as well. Reservoirs behind dams displace wildlife and people. They also cover cropland. Dams can disrupt the natural migration of fish. The sediment carried by a river is deposited in the reservoir behind the dam. Over time, sediment slowly fills up the reservoir. This leaves less room for water. Groundwater. Groundwater for supply Groundwater for water supply is pumped from porous material below the surface. An aquifer is any body of sediment or rock that contains water. The rock has to be of sufficient porosity to provide an adequate supply of water from wells. The best aquifers are made up of loose and porous sand and gravel. Fractured bedrock can form good aquifers as well. In rural areas, most homes have their own wells to tap groundwater. Many towns and some small cities obtain part or all of their water supply from several large wells. These wells pump groundwater from large aquifers. Most aquifers have a free connection up to the surface. These are called unconfined aquifers. The water is replenished by downward percolation of surface water. The sand in your model was an unconfined aquifer. Addition of new water to an aquifer by the downward flow of surface water is called recharge. Some aquifers are isolated from the surface. They are separated from the surface by an overlying layer of impermeable material. This layer is called an aquiclude. Layers of fine clay are very good aquicludes. Confined aquifers cannot be recharged from directly above. Their recharge areas may be located far away. They can even be tens or even hundreds of kilometers away. Okay, in Figure 4, the signs show the approximate position of the land surface in 1925, 1955, and 1977 in the San Joaquin Valley, California. Switching to surface water slowed the rate of land subsidence, but new groundwater pumping during a drought from 1987 to 1992 caused further subsidence. In many areas where groundwater has been used for a long time, the land surface has subsided or sunk down. This is because so much water has been withdrawn. One example is Edwards Air Force Base in California. The land there has subsided more than 2 meters. This has damaged some of the runways once used by the space shuttle. Aqueducts. In some areas, water use is greater than local supplies. Water must be brought in from distant areas where there is lots of water. This is the case in California. About two-thirds of California's precipitation falls in the north. However, about two-thirds of the population lives in the south. A system of reservoirs in Northern California supplies Southern California with water. This water is transported through a system of large surface pipes and channels. They are called aqueducts, as seen in Figure 5 below. Over long distances, the water in the aqueducts flows downhill under gravity. In some places, enormous pumping plants must raise the water up over hills and mountains. In Figure 5, you can see this aqueduct in Southern California carries much needed water over long distances. Desalination. Seawater can be converted to fresh water. This process is called desalination. It is still too expensive to be widely used. It is used in some arid countries that are located near the ocean. Israel and Saudi Arabia obtain much of their water from desalination. New and less expensive techniques for desalination are being developed. The process will then become a more important source of fresh water in many countries. Water conservation. Conservation is a great way for a community to stretch its water supplies further. The community then does not have to develop new supplies. The water supply stays the same. However, if the community uses less, then there will be more water for new development. You will learn more about conservation in the next section. Water budgets. A financial budget is a plan for how to use money. An individual or family, a company, or a government can all have budgets. The budget outlines expected expenses and the income needed to cover them. The term is a bit different in science. A water budget accounts for the sources of water supply and water demand. Also, it accounts for how the supply is divided among the various demands. Studying a water budget can help us to identify parts of water use that need attention. By doing so, natural scientists, engineers, planners, or government officials can work to find the best options for the use of water. They can also come up with solutions to potential problems. In most regions of the United States, rainfall varies from season to season. For example, in some locations, riverbeds are dry during much of the year. The the rivers flow only during storms. In other places, rivers flow all year long. They even flow during months with little rain. Can you explain these differences? Groundwater is a major source of water supply in the United States. One advantage of using groundwater is that it is not as vulnerable to short term changes in precipitation as surface water. As you will learn, however, the groundwater table goes up and down as well. Rivers. The volume of water that flows past a point on the river per unit of time is called the stream discharge of the river. It is measured in cubic feet per second or cubic meters per second. Large rivers, such as the Mississippi, Missouri River system, can have discharges as great as 16,800 meters cubed per second. In most rivers, discharge varies greatly between times of drought and times of floods. Most places that use rivers for water supply use Most places that use rivers for water supply use excuse me, Most places that use rivers for water supply use only a small bit of the river discharge. In some places, however, the demand for river water is great. In those areas, the discharge is greatly decreased. For example, much of the discharge of the Colorado River in the southwest is used for water supply. So much of the water is used that by the time the river reaches its mouth in the Gulf of California, the flow is only a trickle. Not all the water in rivers comes from surface runoff. Rain also infiltrates into earth to become groundwater. Remember that after a certain depth below the land surface, the rock and or sediment is saturated with groundwater. Flowing rivers, as well as lakes and springs, are places where the water table comes out to the land surface. At times of high river flow, some of the river water feeds the groundwater, as shown in Figure 9a. At times of low river flow, however, the groundwater feeds the river, as in Figure 9b. This is why most large rivers flow even during long droughts. On average, groundwater supplies as much as 40% of the water that flows in streams and rivers. During times of drought, the percentage is much greater. During times of flood, the percentage is much smaller. In Figure 8, the water table comes to the land surface at flowing rivers. In Figure 9a, it shows the high river flow, and Figure 9b depicts low river flow. Groundwater. At some depth below Earth's surface, the porous rock and sediment are saturated with groundwater. The upper limit of saturation is called the water table. Above the water table is the unsaturated zone. In this zone, most of the pore spaces are occupied by air. Below the water table is the saturated zone. All the pore spaces are filled with water. This water flows slowly toward areas where the water table is lower. Those who rely on groundwater would find life easier if the height of the water table always stayed the same. Variations in rainfall affect the height of the water table. During dry spells, groundwater keeps flowing toward lakes, rivers, and the ocean. However, there is no recharge to keep the water table from falling. During rainy spells, on the other hand, recharge more than makes up for the groundwater drainage. The water table rises. In many areas, the difference in the height of the water table between dry spells and rainy spells can be many meters. Before wells are drilled into an aquifer, discharge and recharge of the groundwater system is in a condition of long-term balance. The amount of water entering the system is balanced with the amount leaving. Also, on average, the height of the groundwater table stays the same. Pumping of groundwater for water supply upsets this balance. As water is pumped from a well, the water table drops near the well. It takes on a conical shape. This is called a cone of depression. This is called a cone of depression. If water is being pumped from several wells in the same area, the cones of depression merge with one another. The water table is depressed over the entire area. When groundwater is pumped from a field of wells, one of two things can result. The first is that the water table could be lowered. However, it can become stabilized at some lower height as additional groundwater flows into the area from surrounding areas. The second is that the inflow of groundwater from surrounding areas might not be great enough to stabilize the water table. This level would then keep falling indefinitely. In that case, the groundwater can no longer be thought of as a renewable resource. It is being consumed faster than it is being replenished. In a real sense, the groundwater is then being mined. In some areas of the United States, there is an imbalance between recharge and discharge. The water table has been lowered by as much as 100 meters over the last 50 years. Eventually, the cost of pumping from great depths becomes too great. If the wells are not deep enough, they could also run dry. If these things happen, new sources must be developed. Water resources in the United States. Total water use in the United States in 2010 was estimated to be about 355 billion gallons per day. This includes both fresh and salt water. For the entire country, groundwater resources supplied 79,300 million gallons per day. Surface water supplied 275,000 million gallons per day. The use of groundwater and surface water supplies vary by state. The factors that determine the water supply use The factors that determine the water supply to use include geology, climate, and topography. Figure 11 shows the pattern in the United States of surface and groundwater withdrawals. Figure 12 shows the distribution of major aquifers in the United States. As you can see, they occur mainly in sedimentary rocks, as there are some aquifers in volcanic regions as well. So here is the major aquifers in the United States, regional water quality assessments of principal aquifers.